Hello and welcome to our new unit, Trig Identities, which is not really a new unit. It is the new chapter in our book though. Trig Identities should be familiar. We have our trig expressions, sine, cosine, and tangent. And we know that there are reciprocal identities. Cosecant is the reciprocal to sine. I would definitely copy this down into your notebook just so we have kind of a refresher. Cosecant is the reciprocal to sine. Secant is the reciprocal to cosine, and then cotangent is the reciprocal to tangent. So definitely get these down. They are going to be very, very useful in this particular unit. There are extra ones here as well. Tangent is technically y over x, but we could also write it as sine over cosine. And there are technically two for cotangent. You could write it as 1 over tangent, or you could also write this as cosine over sine. And if you notice, that is just the reciprocal. Tangent, sine over cosine. Cotangent would obviously be the reciprocal, cosine over sine. So those, pretty much these three you should know. You should also be able to rewrite cotangent into cosine over x, and then you should know that tangent already is sine over cosine. But where it gets tricky, or a little bit muddy, is with these trig identities, these Pythagorean identities. Now, we should, for sure, at the very least, know the sine squared plus cosine squared is equal to 1, okay? The other ones can be, if you want to memorize these other two, you can definitely derive them. You could memorize them, that's perfectly fine, or you could derive them on your own. And the way you would do that is, and if you remember this from our first unit of the chapter when we started with the unit circle, all we did was divide the original equation, sine squared by sine squared, every term. And if you did this, sine squared divided by sine squared is 1. Cosine squared divided by sine squared, that is cotangent, but it's cotangent squared because we're working with an exponent of 2. And 1 over sine is technically cosecant. So this would be cosecant squared, x. We have a plus sign here, we have an equal sign here, and if you notice, this is the last equation here. So I'm going to call this, I'm going to break this down a little bit so it's a little bit easier to reference. Erase all this. And technically, yes, we would be able to do the same thing if we divided all of these by cosine squared x, cosine squared x, cosine squared x. We would get this equation, okay? If you don't believe me, actually work it out, and you'll see that it turns into tangent squared x plus 1 is equal to secant squared x. Now, what I need us to take away is this. This is our main equation. I'm going to call this 1a. I'm going to call this second equation 2a. I'm going to call this third equation 3a. The reason why I'm doing this is because we're going to create alternate versions of these exact equations. What I mean by that is this. What if I wanted sine squared x completely by itself on the left side of this equal sign? Well, that means we would have to subtract cosine squared x. And whenever you subtract things from one side, you have to subtract it from the other, and you get a new equation. So our 1b of this equation is this. So that's 1b. Sine squared x is going to be by itself. It's equal to 1 minus cosine squared x. And that's what this is on the right side of the equation, okay? So that is an alternate version of this first equation. All we did was bring the cosine to the right side, and we could see that it just looks different. Now, technically, we could also do this, a third version of this exact equation, because what if we wanted cosine by itself? Well, that means we would have to subtract sine x from both sides. I'm going to stop right there. And if we subtract sine squared x from both sides, we should get 1 minus sine x squared on the right side. And we should get, so this is our 1c, we should get cosine squared x is equal to, because this is gone, 1 minus sine squared x. Okay? So here we have two alternate versions of the exact same equation. They just appear differently. The reason why I want you to do this is because we're going to reference these in our practice problems, and then you'll see it in your homework. Now, the same thing happens here in our 2a. What if I wanted tangent by itself? Well, all we have to do is get rid of this plus 1. Opposite of plus 1 is a minus 1. So we should get tangent squared by itself. And we should get it equal to, since it's subtracting 1, it should be on the tail end, secant squared x minus 1. Now, same thing, so this would be our 2b. Okay? So let's draw a little bit of a vertical line to separate this. And then let's go with the 2c. Because what if I wanted the 1 by itself? Well, that means I need to get rid of the tangent squared x. So we subtract it from both sides, and we get 1 is equal to secant squared x minus the tangent squared x that we subtracted from the left side. And there we have two alternates of that exact same 2a equation. Okay? Now the last one I want to talk about is this 3a, 1 plus cotangent squared x is equal to cosecant squared x. And we have two alternates as well. So if I wanted cotangent by itself, I would subtract 1 from both sides. And we should get, this is going to be our 3b. We're going to have cotangent squared by itself is equal to cosecant squared x. And then we subtracted the 1 from both sides. And there you have it. Last but not least, if I wanted the 1 by itself, I would subtract the cotangent x. So we should get 1 is equal to cosecant squared x minus cotangent squared x. And now we have 9 different versions of pretty much the exact same set of, pretty much everything stems from this particular Pythagorean identity. So if you know this one, technically you could create the other two. And then from there, you could create the alternates, okay? But ideally, I want you to be able to recognize these equations, okay? You need to be able to look at something and say, okay, I have a cosine squared, I have a sine squared, I could use some iteration of this row of equations, or a column, okay? Same thing happens if I have a secant squared and a tangent squared. I should be able to use some iteration of the column 2. And last but not least, if we have cotangent and cosecant, we should be able to use an equation from column 3. So let's get some practice in. Sine times cosecant. Well, if you want to break this down completely, well, sine would just stay itself. Sine theta. Remember, this is for theta, and it's just an angle or radian. But cosecant is technically 1 over sine. So what happens when you multiply reciprocals with each other? It's like what happens when you multiply 1/2 times 2 over 1? Well, the 2's actually just cancel each other out and you get 1. Same thing happens here. Anytime you're multiplying reciprocals with each other, they should be equal to 1. Okay? So that's the general idea. We want to be able to rewrite our trig expressions so that we could cancel things out. So let's take a look at number 2. Now, cosecant squared, we have a secant squared, which is technically 1 over cosine x. And we have this multiplied with cosecant squared x. Now, I'm going to actually break this down into anything that's squared is just repeated multiplication. So I'm going to rewrite this like this. Cosine times cosine is cosine squared, right? But if you notice, we have a cosine in the numerator and a cosine in the denominator. So one set of those could actually cancel each other out. And we're left with just cosine of x. And technically, it'd be 1 times cosine, which is cosine. 1 times 1, which is 1. But you don't need to do all that. You can just leave it as cosine of x. Okay? Number 3, getting a little more complicated. Let's break this down. Secant is 1 over cosine of t. Remember, all these letters, whether it's a theta, or whether it's x, or whether it's t, it's just referring to an angle measure. So, secant t is 1 over cosine. Sine is just sine of t over 1. And then cotangent. If we need to recall, cotangent is cosine over sine. Technically, you could write it here too, but it'd be easiest to use the cosine over sine. Let's make sure we use the right letter. We're using t here, so cosine of t over sine of t. And if you notice, we have cosine in the numerator and denominator, so those cancel out. We have sines in the numerator and denominator, so those cancel each other out. And now all we're left with is 1 over 1, which is just equal to 1. Number 4. Now we have a trig expression outside of a group. And hopefully your instincts tell you should distribute. If you thought that, perfect. That's exactly what you should do. when you multiply this, it's still going to be sine times cosecant is 1 over sine. Sorry, I should put a theta here. And then we have a 1 minus. We should have sine theta over 1 if you want to do that. It's not completely necessary because when you distribute this properly, sine times 1 over sine, those actually cancel each other out because they're reciprocals. You should get 1. Then you should get a minus still. And then sine times sine is sine squared. Now this should be hopefully a giveaway because we have 1 and we have a minus sine squared. If we go to our equations, we have some version of column A, or column 1. If you look closely, 1 minus sine squared is right here, and that is technically equal to cosine squared x. So here, we have that exact same thing. We could say that this is equal to cosine squared theta, because we're using theta in this particular problem. Okay? All right. So, number 5. Let's break this down. Cosine will stay the same, plus sine will stay the same, but we know tangent is sine over cosine. And this is where it's going to get tricky, because technically, this is over 1. You can multiply all of this. Sine times sine, sine squared. 1 times cosine, cosine. And this is the hard part. Most people will get stuck here, because how do you add this? Well, if you want to put a 1 over this, you absolutely could, but whenever you're adding with fractions, you need for instance, if I added 1/3 and 1/4, you need a common denominator. You need an LCD. In this particular case, we just multiplied 3 and 4 to get a common denominator of 12, and you multiplied both the numerator and denominator by the specific values that will give you 12 as a denominator. So then in this particular case, this first one, this should be 4 times 1, and then 3 times 1, excuse me, and then we should get 7 over 12. The same thing actually happens here. So let me erase all this. We don't need this. This is just the concept. We need a common denominator between 1 and cosine. Well, 1 times cosine is just cosine. So our LCD here is equal to cosine. So that means we're going to multiply cosine of x in the numerator and the denominator. And when we do that, we'll get a new value. Cosine times cosine is cosine squared. 1 times cosine is cosine. And then now we can add this together. We have cosine squared, we have sine squared x, and we have a common denominator, so we could write this all under 1 bar, or 1 fraction. So this would be cosine squared plus sine squared all over cosine. And if you notice, this is an identity. Cosine squared plus sine squared should be equal to 1. It's our 1a, right? There's our 1a. Cosine, sine, it's written in a different order, but it's the same idea. So we could rewrite this technically as 1 over cosine x, which is technically the reciprocal to cosecant. I'm sorry, secant. And this is our final answer. All right, last one. Secant squared x minus tangent squared x plus cotangent squared x. Now, hopefully all the squareds is a red flag to, oh, I probably need to use a Pythagorean identity. And if we look closely, secant squared x minus tangent squared x is part of our identities. So if we have secant squared x and tangent squared x, and they're subtracted from each other, we have it equal to 1. So we could definitely use that identity. Secant squared x minus tangent squared x is equal to 1. So we could say that this will be equal to 1. And now we have 1 plus cotangent squared x. Now we should look for this as an identity. Well, 1 plus cotangent squared x, we have cotangent squared x here, and it's actually this first one. 1 plus cotangent squared x is equal to cosecant squared x. So in this particular case, this identity turns into, what did I say it was? Cosecant? Yes, cosecant squared x. and we are done. Okay? So, we're gonna get a lot of practice with this. Remember, all this is just fancy fraction work. Reciprocals, if you're multiplying reciprocals, they should always equal 1. So sine and cosecant, cosine and secant, tangent and cotangent, they should always equal 1 if you're multiplying them. And do your best to have, I would definitely say, at the very least, these memorized for now, and this one. If you're a little more advanced, definitely get these as well. Okay? All right. Other than that, have a good one, and I'll see you in the next one. Bye.